Okay, I think we're live. Let's double check. Good evening, everyone out there. How is everyone doing this evening? Make sure that everything is working on here correctly. And yep, looks like we're live there. And we're live here. Yep. Good. Okay, so we have a lot to talk about tonight. For one, we got a storm coming up for tomorrow. That's going to be producing some rain. Overall, not a major impact, but because it's St. Patrick's Day and people want to do parades and everything else like that, especially around New York City, it will have somewhat of an impact, especially with the potential for about a quarter of an inch of rain to as much of an inch of rain, depending on the evolution of the storm. We'll talk about that. We got some interesting pattern evolution that I'll touch on with the polar vortex and also with La Nina. And also, I wasn't going to touch on this, but I'm already starting to see it all over social media. People posting snow maps for things that are 10, 15 days out, which I don't know why. But I'll explain very quickly why that is not the case, or at least why you should trust something. You think that we'd learn it from this previous weekend where there were some individuals going with 2 to 5 inches on the I-95 corridor, and we ended up with like a trace. And the reason why, based on the fact of the time of year, but we'll talk about that in a minute. And also some really cool news coming out from NASA about them creeping closer to achieving fusion. Now, you know, I've been talking about fusion quite a bit because I am a realist and I like to see solutions that actually are beneficial not just to activists, but also to the average person on how to get away from using fossil fuels. Okay. And I think that fusion is one of the best ways to do this, okay, along with other things, but I think fusion's the way to go on this. So some really interesting data and information on that. And of course, I will take your questions as well. And we'll go and cover that in just a few minutes as well. So first, let's take a look at the observations and take a look at our nice little storm here that is developing over the southeast. We have a closed upper level low, a nice low pressure system around 1011 millibars. Not incredibly strong because now it's vertically stacked. What that means is that your surface low and upper level low are basically over each other. And the next low pressure system to intensify is going to be this one. The reason why is that when we look at the structure here, and we'll start off at the upper levels, and you have your 500 millibar low, and let's jump down to 850 millibar low. They're both vertically stacked. So your best divergence and diffluence and strengthening is basically right here around Georgia, which happens to be where your surface low is. So what's going to happen is that this low will continue to weaken, this one will strengthen and lift to the northeast towards the Delmarva Peninsula. So what we're going to be watching out for as this evolves is the moisture transport, this right here. See, as this upper level low starts to weaken and we start to get a new upper level low start to shift to the east here, you're going to see a stronger influence coming in from the Atlantic Ocean. Now, the models even now are having a little bit of a difficult time trying to handle that evolution. So you're seeing some of your mesoscale models, especially the HRR, going with steadier rain, and then lighter rains, then steadier rain. So it becomes a question of the forecast of how much rainfall is actually going to be a factor as we move towards tomorrow. Now, I know for a fact a couple of things. One, this is going to be focused towards the coastal plain. Here's your upper level low, very nicely here on the water vapor satellite picture. What we will look for is that as the main storm jumps to the east towards South Carolina and then up towards the Delmarva Peninsula, you're going to get this moisture transport starting to become mature. And that's going to lead to forcing right along the coast. So you'll see this band of moderate to heavy rainfall late tonight through tomorrow morning march northward from Virginia through the Delmarva Peninsula and up towards the Jersey Shore, and then swing out through Long Island. The question right now is just how organized that feature will get as we get to tomorrow morning, and that will pretty much decide whether or not we're dealing with just scattered showers or periods of moderate to heavy rainfall that's persistent. Either way you slice it, if you're going to a parade tomorrow for St. Patrick's Day, whether it's in New York or wherever, New Jersey, wherever, you're going to need an umbrella because it's going to be raining quite a bit, at least in the late morning and early afternoon hours. Now, the forcing mechanisms are pretty much the same. Okay, we'll take a look at 700 millibars here for frontogenesis. And we'll use the European guidance. It loads in. And then, by the way, we're also going to talk about daylight savings time, which is really ticked me off that Congress once again just blew this. But we'll talk about that in a moment as well. So here is our forcing. Now, the European guidance is not as well organized. You get some evolution here, but not a lot, because it's slower in developing the new coastal low in the mid-levels. So by the time that happens at 700 millibars, everything's already starting to head out. But the NAM guidance, let's see if I can pull up the NAM guidance here. And incept NAM. Oh, here we are. Let's pull up some of the forcing parameters here. Okay, perfect. Precipitable water. Let me zoom in. And there we go. Okay. The NAM guidance is driving more moisture into the coastal plain here. And that's supported by a stronger jet streak evolution because the 850 millibar low and the mid-level lows are forming faster. So I'm kind of going in between on this because what I'm seeing right now in the upper level winds is that our 500 millibar low is starting to go into a negative tilt here. Very slight indication right here of that process beginning. And then when we go to 850 millibars in the latest observations, you can start to see the transition starting to take place further to the east. So I think that this whole process is going to cause this jet streak right here start to tilt more to the southeast and start to drive in moisture from the Atlantic into the coastal plain from the Delmarva Peninsula up to Long Island. So I'm kind of splitting the difference here on how this whole process takes shape. Because if you look at the European guidance, we're not quite ready for 18Z just yet. That's going to be after the chat by the time it really comes in. But you could see on the European that it's more scattered in nature because it's slower to develop. But on the mesoscale guidance, on the NAM and also on the HRR, you'll see it's a bit more organized, especially the 18Z. And then we take a look at the HRR guidance. And we'll use the regular simulated radar here. You can see this is a more organized system. So I'm kind of going to split the difference here. I think what we're going to be looking at tomorrow is broken areas of steady precipitation along the coastal plain. And I mean right along the coastal plain. So I would say Cape May up through Atlantic City, through, let's say, central Monmouth County, and on the south side of Long Island, I think you're going to see some more steadier rainfall. And then the further west you get, the more scattered it will be. And then out here towards the Poconos, isolated, not much at all. I don't think everyone's going to see over a half an inch of rain, but I think there's going to be pockets here and there based on some heavier downpours. But I don't think it's going to be fully matured like the HRR is showing. But I think it's going to be more organized than what the European is showing right now, based on the observations that we're seeing and the way that this rain shield is organizing here. Okay, you're already starting to see that with this rain shield starting to blossom here, our secondary low is getting closer and closer to becoming the primary low, and that's being further enhanced by the convection here and the latent heat release associated with this area. So here's our surface low, our old primary, with the upper level low over it. That is going to continue to weaken. This will strengthen because this is under an area of divergence and diffluence, which we could start to see stronger, colder cloud tops out here to the east. And here's our upper level low. Here's our divergence and diffluence. And here's the upper level low right over it. And you can see that also with the various analysis. So that's where I'm seeing us moving forward for tomorrow in terms of that rainfall. Then we remain in a pretty active pattern. I mean, we got another warm front that's going to be moving through on Saturday morning with additional showers. Cold front follows through. And we have another active storm coming through later in the week. Now, let me pull up the GFS guidance and kind of get this out of the way here, because some people are using the 18Z GFS to talk about a storm. So I wanted to touch on that, and then I'll talk about some other comments. And we are also active here on YouTube. I'll get to your questions as well. Okay, so this solution out here. Okay, a couple of warning points before we start getting all too excited about this solution on the GFS. And we'll zoom in on it. Let's see here. Okay, first problem I see in this scenario, if you want to go with a 10-to-1 snow map that some people are already posting out there. First of all, it's in the middle of the day in late March. Okay, we already know what the sun angle can do. So anything that you're seeing on a snow map, you probably want to cut it down by at least a quarter to a half of what you're actually seeing. Second of all, the evolution of the pattern strongly depends on a progressive negatively tilted trough. In this scenario, this time of year, with again weak high latitude blocking, it's difficult to pull off a thread the needle type of event this late in the season. Can it happen? Yes. I would want to see a stronger negative NAO pattern in order to trust a solution like that. The only reason why I'm touching on it is that you're likely to see this floating around all over social media the next couple of days. Regardless of what the model guidance puts out the next couple of runs, you'll see this snow map floating around. Don't get excited about it. Don't worry about it, okay? I would definitely basically ignore it. Okay, if you start seeing people posting about it, just ignore it. It's just hype right now because it's really, really poor data and really a bad idea, let alone 10 days out, almost 13 days out to put out snow maps. So it's a bit silly and idiotic. So this weekend, though, definitely a good idea for Saturday. If you have plans for Saturday, most likely you're going to probably want to postpone them till Sunday in terms of any type of outdoor activities. Now, the next topic I want to talk about is the daylight savings time influence, okay? The reason why I'm very much against sustained or permanent daylight saving time is that, one, it messes with your model times. Now, in the summer, it's not too bad. You're not having a significant widespread winter weather event. But you're pushing the model output times an hour later, which means that you're issuing watches and warnings an hour later for major winter storm events, which at times can lead to being able to do updates way too late. Okay, I think that is an issue in itself. The other factors, I mean, there's numerous studies showing that if you want to correct a lot of the issues with people handling with time changes and whatnot, the experts say that you should go to standard time. People point to economic improvements with daylight savings time. There is literally no sustainable data to show any type of meaningful change, especially in our new economy where pretty much people work at various times, no matter what, just depending on what their job is. I mean, a lot of people are working from home now. Some decide to work in the morning, some work in the evening. So it's not really a factor anymore because we're not in that type of economy where it's a lot of manufacturing, a lot of farming. It's more of service and a lot of digital. So really, whether or not there's daylight or not, or whether you get an extra hour of daylight, which you really don't, it's really not really an issue. And not only that, but in terms of farming, farmers were actually against daylight savings time to begin with because it alters the natural cycle which they want to follow. So I always thought it was a bad idea to begin with, but then going with permanent daylight savings time is insane. And all the experts who study this stuff all say, no, you should go to standard, which is what I thought we were going to do. But then again, ask the government to solve a problem, you guarantee to have an issue. So I'd love to get your point of view on that as well. And now, talking about the pattern overall, some interesting factors going on with our tropics and with the La Nina. There is some indication that our La Nina could be sustained through the summer. Now, I am holding off on trusting that factor until I get far enough away where the exiting Kelvin wave is no longer an issue. I understand what they're looking at, and they're looking at some of the factors in the subsurface recently cooling. But I want to move away from that Kelvin wave influence because what a Kelvin wave does is that it causes an environment where it leads to warmer water initially. So it weakens the La Nina, or when we have an El Nino, strengthens it. Then when it leaves, it causes cooling. So what we're seeing right now is that cooling factor. Once we move away from that, which I'd say give it another 10 days or so, then we get the true feature of La Nina and where it really is at right now. What I like to go with when we're dealing with these temperature fluctuations is continue to go with the SOI, which has not led me wrong all winter, which continues to suggest we have a weak La Nina influence on the atmosphere, okay? So I have liked and I continue to like the idea of a La Nina influence through the spring. I really like that idea, and that means that we're going to have an active severe weather season in the lower Mississippi River Valley, up through the Tennessee River Valley, and into the southern Mid-Atlantic, possibly pushing into the northern Mid-Atlantic. Watch out, Philadelphia Metro, okay, in terms of severe thunderstorms. If this continues into the summer, I like the idea of more of a cold neutral. I do not see an El Nino showing up in any way, shape, or form in any of the observations or anything of that nature. So I'm throwing that out. I'm thinking you're either going to be dealing with a cold neutral environment where, and let me pull this up again, where your sea surface temperatures are slightly below normal. So like we're talking about like minus 0.3, minus 0.2, something of that nature Celsius, rather than minus 0.5 or minus 0.7. or we get a very weak La Nina influence. And what that generally means for our summer and also for the tropical hurricane season would be very similar to what we saw last year. An active severe weather season for the northern mid-Atlantic and the southern mid-Atlantic, more so for central New Jersey on south through Virginia, also back through the Tennessee River Valley and towards the lower Mississippi, mid-Mississippi River Valley, southern plains. I like the idea of a wet weather pattern for us. I'd be concerned about, I would be prepared now for the potential for flash flooding heading into the summer. Okay. So basements, whatnot, I'd definitely prepare for that. I also like the idea with our Atlantic showing a clear negative AMO influence here of your focus for tropical systems to pop up in the Gulf of Mexico, the Western Caribbean, and the Northern Atlantic. Much like last year, I do not like the idea right now with going with a series of Cape Verde type storms going from Africa all the way into the East Coast. I don't see that right now being a theme. I'd see a very similar hurricane season to what we saw last year. And beware of the tropical system or the subtropical storm that pops up around the Bahamas and around the Keys to create some mischief for Florida on northward. So those are my preliminary ideas on that. So we'll see, and we'll flesh that out as we move forward over the next couple of weeks. Combine that with what we're seeing with our polar vortex. Now we're seeing another major warming event taking shape. Right, if I can pull up the right number. Okay, so here's our stratospheric warming event that has been taking place. And we'll march it right through. It's been cold. Here comes our warming event, pushing up through. And it's very warm right now. This warming event will last for about another couple of days, and then we start to see it reduced in intensity, and then we start to see the polar vortex start to collapse as we move into spring. So what that looks like on our 500 millibar, on our 10 millibar forecast here, is that the polar vortex initially splits here. But the one that's over North America and Greenland essentially collapses. And your primary focus is over Asia. And we also see that at 50 millibars, even faster. And we also are seeing that on the GFS. Let that load. We'll do 12Z so that way it matches up. You can see that take shape. So we have the split, collapse, forge into one, and then steady weakening thereafter as we move further and further into the spring season. So what does this generally mean? It means that if you're looking for, because of the split of a cold active pattern and a stretching in the polar vortex, the polar/Pacific air masses that are going to impact North America are going to be very transient. So you might get a day of below normal temperatures and then a rapid rebound. If you're looking for sustained cold and high latitude blocking to produce storms, you're on the wrong side of the earth. You want to go towards Russia and also towards Eastern Europe and China. That's where that's going to be focused based on this evolution, not North America. North America, I think, with these type of winds, and we'll do the European first. Take a look at this. This goes out to 120 hours, so about 5 days out, and you can already start to see that influence coming in from the Pacific and any type of influence from the polar vortex evolution getting focused towards Canada and then getting shunted out into the Atlantic. And on the GFS ensemble guidance, essentially seeing the same thing again. We'll do 12Z to make it comparable. And I like using 100 millibars for this because it's kind of like that bridge between what's going on with the stratosphere, what's going on with the troposphere. So you can kind of see that interaction a little bit better. And again, as we move forward, what you end up with is this more of an influence from the Pacific here. So what you generally get here is more of a polar Pacific air mass that's trying to drop in. All your Arctic air is locked up back here in Siberia. And you generally get very, very weak transient polar air masses and more of an influence from the Gulf Coast and from the plains and Pacific air masses coming right through the Rockies and downsloping and modifying very quickly heading towards the East Coast. This is a signal for near to above normal temperatures, not sustained below normal temperatures. You might get a cold front that produces below normal temperatures for a day, but those below normal temperatures are the 40s and 50s at this point, not 30s or anything of that nature. This factor is also why you want to stay away from any type of winter storm signal as you move further and further out in the model guidance. Again, especially beyond 7 days, any signal like that should be taken with a serious grain of salt. And then finally, I'm going to just touch on some breaking news going on with fusion energy. And the reason why I want to share this is that, I always get climate questions. I like to always find climate solutions. Okay, it's easy to say yes, no, I'm for this, I'm against this. What I like to do is provide you with some of the latest data and information out there in terms of energy improvement and whatnot. And this is really exciting. Okay, now what this chart is that NASA is trying to find a way to use fusion energy so they can propel their space craft. So if you want to go to Mars or wherever, okay, or the moon, easier. And obviously, using the rocket fuel that we use now, you only have so much ability to get out there in the stars. So one of the natural solutions out there is to use fusion energy, which, again, if we find a way to generate enough fusion energy where you could use it as a sustained power source, it fundamentally changes the game on everything. Okay, you don't need oil, you don't need gas, and it's cheap. Okay, so this again is something that I'm really keeping an eye on because I think it fundamentally changes the entire equation. So what NASA wanted to do is that, look, if we're going to use this, we can't have huge lasers and we can't have a confinement system where you have to use a huge magnetic force and put that on a space station because it's not something that's sustainable and it's too large to handle if you're going to be sending people off to Mars, right? So they had to find a different solution. So what they did is that metal, okay, they found a specific metal called yttrium, and the way that it's organized is kind of in a lattice, right? So the way that it's structured is that the hydrogen atoms are very close to each other. And if you just inject some electrons in kind of like a beam, right? An electron cloud screening, it forces electrons and basically creates a fusion that pushes out helium, which leads to fusion energy. Now, the positive thing about this is that you only need a small amount of metal and you do not have to worry about it creating a bomb or exploding or anything of that nature because if the mechanism doesn't work, it's just lays as a piece of metal. Right? It's not radioactive, it's anything. If it works, it produces an output of energy, which you can then repeat and lead to finite energy. Okay. Again, one of the great things is that, like, if the process fails, you don't get an explosion, you don't get a meltdown, you don't get radioactive activity, you just get nothing happening. So what they can do it, they're trying to find a way to create an environment where it can be sustained. And you can read all about this on medium.com. Let me see if there's a way if I can put this into the chat. I'll tell you what, I'll put it on my Twitter feed if I can do that. And there it is. I'll put it on the Twitter feed. You guys can check that out. And what's really cool about this ability is that the evolution of this type of technology will make it available on Earth cheap for every country in the world. And you don't need a huge facility, it's just a very small facility, the same size that you would need for a spacecraft. So there's a lot of interesting potential here in that technology, and we continue to creep closer and closer. And the reason why I bring it up is that it took us 60 years to get to this point. In the past 5 years, we've seen a huge jump in ability and getting closer and closer to making this a reality. 5 years ago, it was a dream just to have an output. Now we're beyond that point. Now we're trying to find ways to make it more efficient. And like I said, I think that this factor, it makes everything else more realistic. If you're talking about electric cars or anything of that nature, it just leads to something that would fundamentally change the game. Okay, so again, very interested to see how this all plays out. Again, I'm looking at this from just a scientific output. I'm not looking at this from a political output because politics is stupid and too many stupid people are involved in it. But just from a scientific point of view, because I am a science nerd and I like to find solutions, I think this is an amazing solution. I think we're getting closer and closer, and I'm really excited about that. So now I am going to take your questions. I'll take care of the premium chat, of course, first, and I'll take the best questions out of YouTube as well. And then we'll go with that. So let's see here. We got a couple good questions from Card, as always. So, the Batcave look. Yeah, I know. It's pretty cool. Thanks. Do you expect rain or rain showers in Piscataway area around noonish tomorrow? Going to be at a funeral. Oh, sorry about the funeral. Definitely periods of showers. I would look for steadier rain around noon, unfortunately. That's going to be your worst time for the rainfall. Hopefully part of that misses Piscataway and you don't have to deal with it too much, but I would definitely have an umbrella handy with you. Something very noticeable looking at using temp filter on Earth New Schools, how much smaller the overall area of cold air is to the surface up through 700 millibars. Also, the polar vortex is perfect setup for cold Asia and Pacific air going across the United States. Absolutely. The retraction, and let's see if I can pull this up real fast. Do temperatures, and we'll pull up surface. And you can see the influence of our season. Okay, let's pull this up. This is pretty cool. So you can see at the surface, very expansive over Asia, and it's just shrinking over North America steadily, where all your cold air is really getting bottled up towards Greenland and northern Canada. You're not really seeing that push south of that true polar and even Arctic air towards anywhere south of, let's say, the Canadian border. And if it does try to push south, it's fleeting and doesn't have a lot of support. Whereas Asia, well, they got plenty of cold air, and it doesn't look like it's going away anytime soon. So there's certainly some impressive cold air masses setting up. And you can also see that pretty nicely here at 850 millibars. The same type of signal here. The 18Z GFS snowstorm are as meaningful as 18Z GFS monster hurricanes. I know, I keep telling people that, but they don't want to listen. So basically, school kids have to go to school in dark during the winter, and people commute to work in dark. Definitely see accident rates going up. Yeah, that's one of the problems. Look, permanent daylight savings time sounds amazing in the summer, okay, because it works. In the winter, when it's going to be dark till 8 a.m., let's see how long people actually enjoy that. I think we're better off going with standard time. I honestly do. Let's see here. Permanent standard time, not savings. Absolutely. Yeah. They're divided into timeline. Why the hell did these people think they could do this? Because they think they know better. I don't know. I don't know what to tell you. Let's see here. Any concern for the kind of flooding, severe thunderstorm, tornado threat for our area like we had last summer? If we actually get a weak La Nina remaining, I am very concerned of a similar setup to what we saw last summer. I would not be surprised if we see tornadoes being a threat. Certainly, with the increase of precipitable water values, hail issues, frequent lightning, all that. If we go more into cold neutral, I don't think it would be as bad, but will still be a threat. But if we still have a pure La Nina being involved here, then yeah, I'm going to be on the lookout for severe weather impacts, which is always a good time. I forgot to bring out this book, but I should have done it. It's what you call bad planning. But one thing that we're going to be looking at as we move forward, and young meteorologists out there, you can find this on AMS. And I would strongly suggest getting this if you're interested in meteorology, going to college, getting this early. Mesoscale meteorology and forecasting. The reason why you want to get this book from American Meteorological Society is that besides the fact that most likely you're going to be asked to get it from college and you can get a discount pretty nicely on the AMS rather than going through the college stores, just a little hint, especially if you're an AMS member or a student chapter member, you get a really nice discount on this rather than going through college. Trust me. This book is really important in understanding everything you need to know about with mesoscale meteorology and thunderstorms and tornadoes. So we'll be referencing this book quite a bit right there for the spring and summer. I'll be pulling out sections of this and we'll be going over this as we move forward into the spring and summer season. But it's an excellent book to have, and it's so much full of information. And if you don't get the equations at first, don't worry. Not many people do. But then you'll eventually catch on, and you'll be ahead of the game when you go to college when it comes to mesoscale meteorology. That's usually, I want to say, sophomore or junior year. I think I had that class. But again, the sooner you get it, the better you'll be. Trust me on that. Let's see here. So we could have a third La Nina winter. I'm not sure about that yet. You know, I want to kind of see where we're at in when we get into the summer and the type of environment we have in the subsurface and the evolution of our winds and pressure. Is it possible? It's possible, but it's extremely rare. I mean, the last one that really was sustained was in the 1970s. We're talking about like 73 to 76. I know one was technically in the 80s, but it really wasn't the textbook. But the last one that was really like clearly sustained was in the 70s. So that kind of gives you an idea of just how rare of an event that would be. So we'll keep an eye on it, of course. But I'm not 100% confident in any way, shape, or form. More like 20% confident that would actually be an evolution. I'd be more likely to believe that we'd get a neutral incidental event and we'll have more influence from the MJO next winter than an actual third La Nina. But I'm just saying it's out there, it's possible. Even with fusion, we still need refined petroleum, not for fuel energy, but for all other products, including from refining, tires, cars, plastic. You're absolutely right. What I would say is do not be surprised if we start to transition away from that with our manufacturing. Okay, I would not be surprised if we do that. There are ways to get around that, but you make a great point. It's not just about what you power and what you use for driving around. There's all sorts of material we're using, from the mic I'm using right now to the TV screens. You're absolutely right. You know, it's foolish just to ignore that factor. But we'll see what happens with technology. Fusion, you said the word cheap. Governments and corporates will find a way to make it expensive. In other words, they will make up the difference in losses. Plus, like card, see, we need oil for a host of other products. Again, I'm kind of not looking. You're probably right from a political point of view. I'm looking at this more as a scientific point of view. And again, this is why I'm not a politician, because I use logic, and that's not allowed in government, regardless of who you support. But I'm just saying that the opportunity there to fundamentally change the game in so many ways in our society with fusion makes me very enthusiastic about our future, rather than doomsday people who think that we're all going to like blow up the earth and burn it up and stuff. I think an entire city can be powered on heat coming from the Great Oakland A's fire sale. Yeah, maybe. God, I haven't seen something this bad since like the Miami, not Miami, it was the Florida Marlins back then, when they nuked their team in the late 90s. If you guys remember that, they won a World Series and then they tore apart their whole team, which if you're a Florida Marlins fan, was just, I felt bad for them, but then again, I'm a Mets fan, so not too bad. But yeah, I feel you. I mean, at the very least, I'll tell you one thing with the Oakland A's. At the very least, the fire sale that they're doing, they're getting some really great prospects. So you can kind of see where their plan is and where they want to move to. So at the very least, I mean, they're getting a lot of top-rated prospects, a lot of top-rated pitching prospects. Whereas when the Marlins did it, they were like trading, like, at the time, I think it was like, some like top-rated offensive players for a guy that like was in AAA on their bench team, on the bench. So, at the very least, the Oakland A's are making good trades. Rob Allen asks, evening, Steve. Evening, Rob. Hope you have been well. I try to be. And I apologize for not being here for the last few weeks. No problem. Hey, Rob, I understand. People get busy. Seeing a lot of interest and slightly concerned signals regarding hurricane season. Any early thoughts? Positives and negatives. The positive is that I'm seeing a real nice signal of a negative AMO. So that means that as waves come off of the African coast, they run into cooler water and they take longer to develop. So that's certainly some good news. Negative. If we get a sustained La Nina, that means we have less shear, and that means any tropical wave that manages to get into this area here is going to have a chance to develop. And we're going to have to really keep an eye on the northwestern Atlantic here for some development, which again puts us in a really bad spot for potential impacts up the East Coast and in the Gulf of Mexico, which is where we do not want them. Another factor here that I really want to keep an eye on is the potential for upper level ridges to become sustained here around the Bahamas, which is typical with La Nina and also typical with a negative AMO pattern. And that can lead to tropical systems rapidly developing around the Bahamas and being a real problem for the Southeast and the Mid-Atlantic for not only hurricane impacts, but also flash flooding impacts. So I'm very concerned about those features. There's a whole other bunch of factors here that we have to keep an eye on as well, including the potential for dry air coming off the African coast here. That could be an inhibiting factor. And also the ability for tropical waves coming in from the Indian Ocean through Africa, whether or not they're going to be strong and organized or they're going to kind of peter out. So those are some wild cards as well that we'll have to watch out for. We had some nasty winters as we came out of La Nina in 76 through 78. Yes, we did. So that's something to always keep an eye on. Overall, the Eastern Pacific Basin looks to be the coolest. I can't recall seeing it a long time. Yeah, pretty much. We haven't seen, again, something like this since the 70s. Let's see. Do you think city and state governments and public will take flash flooding emergency warnings more seriously this summer? That's a tough one. That's more of a psychological question. the general public does not take flash flooding seriously. I mean, that's the honest truth. I've seen way too many people think, oh, I'll just drive through it. And we as meteorologists, it's not a messaging issue with the National Weather Service or with meteorologists in general, because like literally everyone that I know of continues to warn people, do not drive through floodwaters. So it's definitely a concern. I don't know whether or not, I hope that people take it more seriously. And hopefully some of the infrastructure spending that we see kind of starts to address those issues. So let's take a look at what's going on in YouTube. Let's see here. And let's see if we can get some good questions. When will thunderstorms start up again? I would not be surprised to see some thunderstorm impacts moving into next week. In fact, maybe on Saturday evening. Nothing severe, but something just to keep an eye on. Let's see here. Let's see. I got some good. Is the summer going to be above average temperature? Okay, is the summer going to be above average temperatures? I think your best potential for heat waves is going to be around the southern Mid-Atlantic through the southeast. I think we're going to have a very volatile summer, much like last year. I would not be surprised if we have limited days in the upper 90s, but a lot of days where we're going to be like 85 to 92 and humid. I think the big story this summer is going to be high levels of humidity. Let's see here. What kind of thunderstorm threat will we have this spring? What type? It's an interesting question. Definitely potential for severe thunderstorms. I think that we'll have an enhanced precipitable water value this year once again. So what that would tell me is that definitely watch out for thunderstorms capable of intense tropical downpours. Watch out for frequent lightning, hail, and I think that we're also going to have a tornado threat, especially in the Delaware River Valley. Let's see here. A lot of people doing, let's see here. A lot of people doing all, oh, okay, I see what Card's saying. Okay, the SUVs. Yeah, SUVs are not invincible. In fact, they're the worst thing you could possibly use to drive through floodwaters because they're too top heavy and they're able to flip over easily. Plenty of those 85 but 76-degree dew points. Exactly. It's going to be one of those summers where, unfortunately, humidity is going to be a real issue. Definitely some good questions tonight, guys. And wow, we're already at 8:48. Time is flying. We got 12 more minutes. So if you have any more questions, definitely get them in there and I will answer them while we're taking a look at the latest data. Let's see if we got any new model data while I'm waiting here. And do you really think it's possible to forecast thunderstorms? Well, yeah, since I've been doing it for 20 years, yes. Yes, I do think it's possible. Are you surprised by the persistence of this La Nina given that it's second part of a double? Slightly. I was noticing a steady weakening trend. The Kelvin wave, not surprising. This is why I want to wait, give it another week or so to see whether or not it's something sustained or this is just a temporary feature. So I'm not really majorly surprised. I'd be surprised if I see La Nina strengthening once we get past, let's say we get into April and we see La Nina strengthening. That would be a surprise. Do you happen to see the August 500 millibar height forecast? I'm surprised we are still seeing such strong latitude blocking showing up. No. Look, I got a... Okay. I do not like to use, nor do I trust those models. That model output or anything involving it. I don't even bother looking at it because, quite frankly, I think it's trash. So I don't bother using it at all. What I use is looking at some of the observational features, looking at how the pattern's evolving. I take that data and then I try to extrapolate it based on what I know. The model guidance that you look at, like that's out to August and all that stuff, um, I think it's highly flawed. I think it leads to a lot of misrepresentation of how the pattern will evolve, and it leads to a lot of poor narratives in our field, especially when people who are not trained in long range forecasting uses it as far as like a media story or whatnot. Um, I just think that it's a waste of computer power and a waste of analytical analysis. Uh, I just don't use it. I don't like it. I don't think it's very reliable, and so I don't bother with it. Our sea surface temperatures, cold pool around Greenland, an indication of areas where we can get persistent high and low pressure this spring and summer. Um, yes, but not yet. I want to see whether or not those cold pools remain as we move into April for the summer. For the spring, yes, it tells me a better potential for backdoor cold fronts, especially as we move through April and early May. But I want to see whether or not it gets sustained or gets stronger to tell me what's going on in the early summer. I wouldn't use that data for, like, let's say mid July to August because there's too many other variables involved there. The other problem with using that data with sustained high or low pressure systems is that we're still asking that question about the La Nina influence and how much an impact that will have on the pattern. So yes, you can use it, but only to a degree. I would use it only out to like 4 to 8 weeks, and that's about it. Because then there's too much variables changing in the pattern, especially in as you move in higher latitudes. And let me see if I can get any new data from the European. I know 18Z was just coming out, so let's see if we got any new data on that. Okay, new 18Z is just out. And yeah, it's supporting, again, your rain focus on the Jersey Shore, but then scattered showers throughout the region. So it looks like middle of the day. Unfortunately, if you have plans, good or bad, for tomorrow during the middle of the day, looks like we're going to be definitely dealing with some rainfall. I see. Saw there was a major earthquake off the coast of Japan today. Yep. Yes, there was. No tsunami or anything of that nature. That's certainly good. Let's see here. Well, I see that we have an interesting person named Opie here. All right. People are weird. That's all I could say. Some people are weird. What time does spring actually start on Sunday? That's a good question. Let's see. Spring equinox 2022. 11:33 a.m. There you go. Let's see. Is the summer going to be above normal temperatures? Like I said, I would say not so much above normal temperatures, but above normal humidity is going to be a theme this year. Let's see. And I think we're going to close it up for tonight based on the questions. Pretty much went over everything I wanted to go over. Here's a good one. Southern Hemisphere polar vortex is starting to kick into gear. Well, yeah, I mean, it's fall over there, so you would expect that to be the case. It's the exact opposite. I have noticed there are some people who try to connect what's going on in the southern hemisphere to what happens in the northern hemisphere. There is literally, I want to make this very clear because I noticed some people, they try to use this in terms of ice and everything else. There's literally no connection between what happens in the southern hemisphere, especially around Antarctica, with what happens in the northern hemisphere. They're two completely different sectors. They are separated by far too many other influences, and they're two completely different type of environmental factors. For one, the Arctic is mostly water, and the Antarctic is basically a large continent. So that in itself leads to far more different features. So I just want to make that clear. Is that part of the question that Card was asking or pointing out? But just I see that a lot. A lot of people trying to take the statistics from the Antarctic and try to translate that to the Arctic. And some people try to create some statistical analysis and try to find causation. But just because you have similar data does not mean that you have causation or a physical forcing parameter. So I just wanted to bring that up in case you start seeing that discussion. I see it every summer. People try to say, oh, there's a massive negative AAO, which is Antarctic oscillation. And so therefore, you also have to translate that towards the Arctic oscillation in the winter. And it fails every time. Every time. Because you don't have any physical connection. Whenever you're using statistics, you can't just use statistics. You also have to use a process to show the physical connection of the statistics that you're showing. Other than that, then it's just happenstance that they happen to be similar. And I think that is about it for tonight. It was a wonderful chat. As always, thank you again for all of your great questions. And I will be back next week, same time, same place. And definitely take your questions as always. And thank you again for making for a wonderful evening. Have a great one. And as always, stay safe out there.